and TSS is 5 ppm. Whereas in three-stage design, we are adding one more process, which is called as anoxic tank. The influent will flow to the anoxic tank, where literally the DO is 0, right? And you have an aeration zone, which is, again, you maintain a DO of 1 ppm. Then again the MBR. Typically, what happens in anoxic cycle is you do the denitrification. You'll come to know, like I'll briefly touch upon like what is nitrification, what is denitrification. In this design, typically you can achieve the parameter of BOD less than 5 ppm, TSS less than 5 ppm, and TN, total nitrogen, which is less than 10 ppm. Nowadays, people are going for this design because as per the new guidelines issued by National Green Tribunal, right? They ask, like, they need the outlet parameter, treated outlet parameter should be BOD 10, TSS 10, total nitrogen 10, and total phosphorus 10. Here we are getting ultimate water quality. Though you are targeting for 10, you are getting 5 here because of the MBR. And the third stage, what we have is 5-stage design, where you have anaerobic at the inlet, where you also do the coagulation and flocculation, because you have in this when you add coagulation and flocculation, right, and there is a recycling happening also, the POS, phosphate accumulating bacteria, will take the phosphorus, right, and releases in the aeration, right. So we are adding an anaerobic process to target the phosphorus removal. You have an anoxic process to target the denitrification process, right? And you have an aeration, which is definitely to remove the to remove the BOD, and the nitrification process happens in this aeration tank. And it is also necessary, depending upon the outlet parameter, because if you see here, the outlet parameter required is less than 1 ppm of total phosphorus and total nitrogen of less than 3. So it is essential that you have to go for a post-anoxic system. Whatever you are doing it in first anoxic, you are going to repeat it in the post-aeration also. We need to add, because usually why we are adding the carbon source. Carbon source is nothing but you add an methanol or a sodium acetate, which is a carbon source, because for denitrification process, it is you need to have the carbon source, then only the denitrification happens, which we'll come to know in the next slide. Then there is an MBR. So in this 5-stage design, it is also called as ultimate biological nutrient removal, where you can get in fact, when I say BOD less than 5, these are the guaranteed parameters what we are telling, but it is beyond less than this, right? BOD less than 5, TSS 5, TN 10, TN 3, and TP less than 1, you can say it's almost negligible. So this, typically you will find these are the 3 stages of design in the market, right? And most commonly used is this kind of design. This is just a graphical representation how a package treatment would look like, right? You have a BOD, influent coming in, which has got BOD, COD, TSS, and FOG, and you have a screen, fine screen, 2 mm fine screen, so that it is essential. Screen is essential so that it doesn't hurt your membrane. So we always recommend. It is always necessary that one should go with 1 mm or 2 mm screen. You have a anoxic basin to do the denitrification, where you convert NO3 to NO2, right? And thereafter you have an aerobic zone where you target the BOD removal, and you're converting you are doing the nitrification, converting ammonia to nitrate, kind of it, right? And thereafter the filtration. And those once typically we maintain the MLSS, so that is mixed liquor suspended solids, somewhere around 8 to 12,000. We try to maintain 8 to 12,000 of MLSS. That means we are trying to maintain the bugs within the system so that it can do its work. Since we are able to maintain the MLSs around 8 to 10,000, your footprint will go down. Hello? Yeah, somebody wants to say something? Because I can see some void.
No, you can go on. Yes.
Okay. So what generally we do is, see, it just out of topic. While commissioning of the system, MBR system, we try to maintain an MLSS of minimum 3 to 4,000 MLSs, right, to commission the system. Otherwise, your membrane will get fouled. So we make sure first this biology is working fine. Thereafter, we pass those water to the membrane basin. Okay, I'll just touch about what is nitrification, denitrification, and why do we care about the process. See, nitrification happens in the presence of oxygen, right? You need an oxygen for nitrification process, and usually it happens in the aeration basin, and MBR basin, right? And it's a typical bacterial. It's an autotrophic bacteria which does the nitrification process, right? For nitrification, this bacteria is also a very slow-growing bacteria. Hence, since it is a slow-growing bacteria, you need to have a longer solid retention time, right? It is essential always when you target for the nitrification. And one more important process is during the nitrification process, it consumes the alkalinity which is available in the influent itself of 7 let's say 7 grams alkalinity per gram of ammonical nitrogen removed, right? And nitrification air requirement, as I said, the nitrification is a slow growing, and it works in the presence of oxygen, right? Typically, it's a rule of thumb, right? If you have to degrade the, if you have to convert ammonical nitrogen to nitrate, right? You need typically 4.57 grams of oxygen per gram of ammonia, right? That's how that is the thumb rule. What we use. So these are the essential parameters. Why do we care about this process? These are the requirement. And what are the tools required, right? Yes, you need an autotrophic bacteria, good autotrophic bacteria with a good solid retention time, right? You need to maintain an adequate DO, right? Dissolved oxygen. It has to be at least one. It's also called as residual DO. Always after bacteria, after giving sufficient DO to the bugs, you need to ensure that the residual DO, which you are maintaining 1.2 milligrams per liter or greater, also will do, right? And alkalinity, again, because it consumes nitrification, consumes alkalinity, so you need to make sure that you have sufficient alkalinity also, right? And pH, definitely, because when the nitrification occurs, if there is no sufficient alkalinity in the influent, your pH will go down below 4 or 5. When the pH go down below 4 or 5, definitely it affects the bacteria. Bacteria cannot work. It will practically get lysed. So this is the process of nitrification process. You need to balance, right, like BOD oxygen and the ammonia part of it, right? And what is denitrification, and why do we care about this process, right? Usually denitrification happens in the absence of free oxygen. Denitrification means if you just remember the previous slides, there was an anoxic basin, right? So in anoxic basin, denitrification happens. There is no oxygen given into the anoxic tank, right? And yeah, it occurs in anoxic basin. And typically, this is an heterotrophic bacteria. This doesn't need much of oxygen to work, right? So it is a separate bacteria which takes care of the denitrification, right? And usually denitrification requires 50% of alkalinity lost in nitrification, right? When you have this anoxic tank, you are recovering almost 50%. Like whenever we design the system, like we take all those credit and do the design of the system, right? What happens is like you are converting from NO3 to N2 gas. That is the thing. Like in the nitrification process, you are converting ammonical nitrogen to NO3. Here you are converting NO3 to N2 gas. So that is a process which is happening, right? And for this process, what are the necessary tools required? Definitely, you need an heterotrophic bacteria, right? You need an no oxygen, I would say, or the free oxygen, and the carbon source, which is essential. That is the reason, if you guys remember, when we give the post anoxic, we add the carbon source uh, at the inlet. When the anoxic is given at the inlet, you don't need this carbon source to be added because already the BOD is coming in. But when you give us, when you put this anoxic as a post aeration, because in aeration you already degraded the BOD. Hence, it is always necessary. You need to add carbon source depending upon the process where you are applying this anoxic tank, right? And recycle nitrates, where you saw recycling is anyways required. So this is about the denitrification process. So we talked about how BOD is getting degraded. We discussed about the nitrification, what kind of bacteria is working on it, and denitrification, like what are the tools required, and what are the conditions you need to maintain for denitrification, right? So by doing this, what kind of water quality you are going to achieve, right? Though I told you it's less than 5 ppm, those are the guaranteed figures. Like being a company, right? We tell it's less than 5 ppm, but actually, what you get is non-detectable. The achievable values is non-detectable. BOD you can get almost negligible TSS, negligible ammonia, though we say less than 1, it's not detectable. Total nitrogen, you can go up to less than 3. This comes with post-anoxic treatment. And the phosphorus, it's typically 0.03. This is after with the process called anaerobic process, which we use, and turbidity, it's 0.05. So you can, even the fecal coliform, you can see it's all typically non-detectable. SDA is a unit that it's called as silt density index. This value is measured if your downstream is an RO system. So this is the water quality you get. Like your inlet will be this, and the typical crystal clear water quality from MBR outlet. Okay. Now, definitely you have many types of membranes, right? People get confused, like which membrane to go. You have hollow fiber membrane, you have flat plate membrane, you have loose plate membrane, you have ceramic membranes. So people usually get confused, like which one to go for it, right? Uh, what you saw now, it's a rosy picture, right? It's good. What MBR does is it gives you an ultimate water quality, right? Less than 5 BOD, less than 5 TSS. No other technology can treat to that level, right? But while it gives you the MBR gives you the ultimate water quality, there are challenges associated also. It's not an rosy picture, right? Any membrane, not only the whatever membrane, you talk about flat sheet, you talk about hollow fiber membrane, you talk about silicon carbide membranes, right? There are challenges associated to it. How you mitigate those challenges in some advanced technology, that is a challenge which I'll be discussing. So what are the membrane challenges, right? Typically, we have identified these are the challenges which any industry faces, right? Number one is you'll see the frequent cleaning, right? You have to clean the membranes frequently, right? you have an issue of durability and robustness. Right? People commit that this membrane can work for so many years, but they'll end up replacement prematurely, right? And you have uh, permeability and recoverability issue, right? Because you design for some flux rate. Flux is nothing but the amount of water you draw from an per meter square of membrane area, right? So usually we design at some flux, but eventually it will come down. You are not able to recover, right? Chemical susceptibility, right? You will find that in many places, even in be it sewage or in any industries, right? The parameters, uh, like if I talk about the sewage, right, you'll find there is an industry which is just dumping those their influence to the sewage characteristic. So eventually, though all the dynamics changes, so some of the membrane are not will not have chemical susceptibility, right? And the TMP, transmembrane pressure, TMP is nothing but transmembrane pressure, the limitation of transmembrane pressure and the premature falling nature. So these are the challenges which have been associated to any membrane, I would say, any membrane, right? One is the recoverability challenges, which we talked about, right? What usually happens is your permeability declines, right? You're getting, let's say, 1,000 liters per hour. All of a sudden, you'll see that you're getting only 250 liters, right? It's a permeability decline. What are the causes? It can be a falling or a clogging, right? Falling is usually a reversible one. It depends because when we get into detail, you'll come to know. Like for falling or clogging, these are the two typical situation which can occur to any membrane, right? Falling is only because of it can be an organic falling or what do you call EPS, like extra polymeric substance. Can bacteria releases the EPS, so by virtue of that, your membrane can get fouled. The clogging is because something to do with on the this fouling is something to do with the process, I would say, right? And the clogging usually happens something to do with your mechanical upstream downstream unit of operation, right? Or your if your blower is not working, like let's say your MBR score blower is not working properly, you can see the sludge cake building up between the surface of the membrane. So then definitely there will be a permeability decline. And what are the operational challenges, right? One is TMP limitation. Usually what happens if you see the top end picture, right? These are the membrane plates. Just assume these are the membrane plates which have been installed, right? You give the feed. This first membrane is clean. Water passes very clearly. If you see the second membrane, there have been accumulation. The third membrane, further accumulation, and the fourth membrane is clogged. So by the time it reaches to this complete clog condition, it will be somewhere around 45 days, right? From 0 to 45 days. Within 45 days, your membrane is getting clogged, or you increase the TMP, because the TMP limit for any polymeric membrane is 3 psi. So the moment it reaches the 3 psi, right, you have to go for a cleaning. Like what if TMP goes beyond 3 psi, right? If you allow the membrane to work to take out the filtration cycle beyond 3 psi, your membrane will get damaged, right? Because it cannot withstand those pressure, so it will get damaged, right? Typically, this we are talking about the polymeric membrane. The TMP material, the type of material dictates the TMP limits, right? For any polymeric membrane, you have 3 psi, but there are membranes available which can go beyond that. I'll just take you to that also now, right? And what are the other challenges? Frequent cleaning, which we talked about, right? It can be mechanical or chemical cleaning. In mechanical, if the membrane is clogged, you have to take out the membrane plates, right? You do the in situ cleaning, chemical cleaning. If it is not getting resolve, you have to take literally each membrane plates and clean it, scrap it out, right? Or you have to do the pressure wash. Pressure wash is not feasible because those polymeric membranes are not good at handling the pressure, so it will tear off, right? And the other option is what you have for chemical cleaning is acid and bleach. Bleach is you can use either HCl or chlorine for cleaning of the membranes. Right. Frequent cleaning also will lead to membrane damage. If you like, if your TMP consistently increases and you tend to clean more frequently, so there are potential chances these membranes will get damaged, right? And we talked about the chemical susceptibility also, right? The membranes which are available in the market, right, or the polymeric membranes, it can take the pH of 3 to 11 pH. So this is the boundary limit. You cannot go less than 3, or you cannot exceed more than 11. So the maintenance during maintenance challenge also, in usually the membrane which polymeric membrane which comes or hydrophobic in nature, right? You cannot completely dry those membrane. If you have to take out those membranes from the tank, right? You need to make sure that you continuously wet those membrane. Otherwise, what will happen is if you allow those polymeric membranes to get dried up, typically the pores get collapsed and it will become an irrecoverable kind of it, right? And once the pores get collapsed, right, you have to replace those membranes. So you need to keep wetting either from a chemical, or you can just use the normal clean water to ensure that the membrane is always wet, right? And the membrane life, right? We talk about the membrane life. What typically happens is, right? You have a new membrane, right? You clean it, you recover it, right? Membranes are bound to um, fall or scale, right? If this is the scenario, it is good. It is reversible falling, right? You operate the plant, TMP goes high, clean it, again you are coming to the original position, right? Which is good. Reversible falling is good, but usually what happens is it becomes irreversible after somewhere around 2 to 3 years, right? Because uh, can someone mute? Yeah, okay, thanks. Okay. What typically what happens, like when you clean the membrane, right? You can see your flux is also going down. You are not having the same flux. You clean the membrane, your flux has gone down. Again, you clean the membrane, further your flux has gone down. Again, you clean the membrane, your flux has gone down. At some point, you are not able to clean the membrane also because you are not able to recover it, right? And that is the point that you decide that now it's the time to replace the membrane. These are the three major reasons for flux decline, right? Sludge dewatering can happen between the membrane plates, right? It can be an organic fouling or an inorganic fouling, right? Which is irreversible. These are some of the pictures of like fouled or dewatered membranes, right? These are dewatered membranes, right? You can see the sludge on the surface of these membrane plates. This is basically a what do you call flat type membranes, flat plate membranes, and this is an hollow fiber membranes. You can see in hollow fiber the sludge got accumulated. It's very difficult to take off in the hollow fiber membranes, and the fouling which happens, you can see that typical fouling, which can be an iron fouling also. It can happen iron fouling or any organic fouling. As I said, see, no membrane is immune to clogging, right? The key lies with the material, right? Since we talked about these are all polymeric membranes, it has got some kind of limitation, right? It is highly chemically susceptible, right? You cannot go less than 3 pH or more than 11 pH, right? It cannot handle more temperature. it cannot handle more transmembrane pressure, TMP. Like once it reaches the 3 transmembrane pressure, you have to clean the membrane. And what will happen, since you will be doing frequent cleaning every 3 psi, you'll be doing the cleaning. That is also harming your membrane, because more cleaning, more frequent cleaning is also not advised for any membranes. Right? This is a recoverability type, like usually use chemical cleaning and mechanical cleaning. Chemical cleaning is used for organic or biological, organic, biological, and inorganic removal. Basically, use bleach, caustic, or acid. Right. This is done through the chemical cleaning. Mechanical cleaning is because of solids, debris, and ragging removal. This can be done either through air wash, backwash, or spray wash, and the manual cleaning also, what you saw in the pictures. So this is how you do it. Okay. And I'll briefly touch upon the operation maintenance portion of it. Usually, when you design an MBR system, right, you need to have some kind of cycle length, right? Usually, it is 9 minutes of filtration, like you filter the clean water for 9 minutes and do the relaxation. Relaxation is nothing but you're not doing anything. Like you're not filtering it out. You're just putting off your suction, right? Staying calm for 15 seconds. Then you do the backwash. Backwash is nothing but the reverse the flow. From where you take out the permit, you are giving water from there, so that you are giving the reverse the flow, so it get backwash. Thereafter, again, you do the relaxation, that is, and further for 15 seconds, everything to settle down. Then again start. So this is the operation cycle for any MBR system which you will see or you come across. And you also do the chemical cleaning, right? How the chemical cleaning is done? You have a tank here. This is a stock chemical supply, and you have a control wall. Water flows from the left to right, right? And you have a pressure regulator, because this is the key portion: pressure regulator and the ejector. It's an ejector venturi. This both are key portion, because for a venturi to operate function, you need certain amount of pressure to typically maintain a pressure of around 1.5 to 2 kg of pressure, so that when the water flows from left to right, you'll see immediately all of a sudden there is a vacuum created, because you in ejector, what happens is you have a throat and a nozzle, right? When water flows from the throat side, right, and it's traveling to the narrow, smaller hole, it suction creates, the vacuum creates, right? So this chemical will get into the system. This side, you'll find the membrane. So this is a just brief idea, like how the chemical cleaning is done. And you have a flow meter just to maintain the flow. Like we need to maintain a certain amount of chemical to be passed through the membrane. So you make sure that those have been done. Right. And the membrane cleaning frequency, usually we call it as CIP, cleaning in place, right? During the maintenance cleaning, right, we advise 28 days, every 28 days, with 0.1% of bleach and 0.2% of acid. And we do have one more type of cleaning. It is called as EMC, extended maintenance cleaning, where you do it once in 6 months with more aggressive kind of it. And the last the portion is, see, these are the application where membrane can be used. It can be used for retrofit. Retrofit is nothing but you are upgrading the existing conventional treatment plant to the MBR system, and it is necessary wherever you have to reuse the system or reuse or recycle. If somebody intends to use this water for an RO system. So MBR will be the best option. And plant expansion, like if you have an existing treatment plant of certain amount of capacity within the given area, you can easily upgrade it to almost 1.5 times. BNR upgradation, that is biological nutrient removal upgradation. You can also upgrade on the process side with while you go with the membrane bioreactor, and it is applied for surface filters, surface water treatment, or drinking water treatment, treated sewage water, or any industrial wastewater. Yeah, that's it from my side. If you have any queries, Mr. Sanjay, Mr. Singh. Yeah, now it is open for Q&A. I'll be happy to answer your queries. Yeah, Mr. SK Singh, are you there? Am I audible? I don't know, Mr. Singh.
Yes, sir, you are audible, sir. You are audible.
Oh, okay. Okay, I think Mr. Singh is not there, maybe.
Right now, he's one NP meeting is there. So
Okay. Hello.
interesting. Sir, Sincere is here. Hello.
Yeah.
Sincere, am I audible?
Hi, Ankit.
Yes, yes.
That's now it is open for Q&A session. I'll be happy to answer your queries if at all you have any questions.
Okay, participants. So one participant has written in chat box, what is done with the scrap obtained after membrane cleaning?
Okay, can I figure out where is the chat box? Sorry, let me see where is the chat box so that I can see the questions.
It's near to on the top. Besides participant, there is a chat box. Or I will ask. I think it may not be visible. It is visible to all. Yes, we can see. I think.
Yeah, sorry, I'm using. I don't frequently use this Microsoft Team, so bear with me. I'm just trying to figure out where is the chat
Okay.
box for that.
What is done with the scrap obtained after membrane cleaning?
No, see, as I told, membrane cleaning is done in two ways. One is chemical cleaning, right, which you do the in situ cleaning, like within the tank itself, within the MBR tank itself, you just inject the chemical and maintain it for 2 hours, 2 or 3 hours, depending upon the scaling or falling which you anticipate, right? And you just start the system, right? That is chemical cleaning. The worst case scenario, in the worst case scenario, what happens is you can see the sludge thickening which has happened, like as I showed you in the picture, right? Where the sludge get accumulated. In some cases, you have to take out those membranes and physically scrap it out, right? We scrape out the sludge, and it is easy to dispose it off. Actually, those sludge are good, right? It's a good in nature. Once you dry it up, right? It's an urea. People use like an urea, so it's very easy to dispose.
Okay. Another question is the membrane filtering is very effective, but it is associated with huge maintenance and disposal problems.
Come again, Ankit. Sorry.
So
The
I
membrane
am
filtration.
yeah, I am Professor Singh only. Yes.
Yeah. Yes. Yeah.
I am reading the comments which is there by the participants.
Yeah.
Here,
Can you just repeat that second question?
membrane filtering is very effective, but associated with huge maintenance problems.
Yeah. See, membrane filters. Yeah, it comes with maintenance. See, we have put. I didn't show the membrane which are better membranes available, because as an OVO we promote silicon carbide membrane, which is far better than the polymeric membranes. But I don't want to bring that into picture, because the most commonly used membranes are these polymeric membranes. Yeah, when you get an ultimate water quality, all right, there are associated problems to it. It all depends how you manage the process and how you operate the system. Yes, I agree. It's a huge maintenance is associated. By then, one doesn't have any choice rather to go with this kind of system, because the discharge norms are getting stringent and stringent, and you have no choice left with.
Yes, one question I want to ask, that for sewage treatment plant, where it is located, this MBR, if any MBR for sewage treatment in
Yeah, yeah,
Gujarat
yeah.
or
Yeah.
yes.
We have many MBRs installed, both for industrial and sewage. Actually, uh, most commonly used MBR is in sewage, because you like the sewage parameters are not that tricky one, complex one, right? And membrane will work, right? It goes for 3 years, 4 years. It gives the life. But whereas in the industrial segment, because now more and more stringent norm is being implied for the industries to go with ZLD system, zero liquid discharge system. That place where you will find the membrane life is half of it, kind of it. So every 2-3 years, you have to replace those membranes. You have
Just
many
I,
systems. You
yeah, good
usually
evening. I
for
am curious to know where it is in Gujarat, where you have you installed anywhere in for sewage treatment?
in sewage treatment, we have in Zydus Cadila,
In
right?
Z, okay, in industry, Zydus Cadila
Yeah,
industry.
Zydus Cadila industry. But they are mixing the sewage also. Like, we are designed in such a way that both sewage and industrial effluent has been mixed, right? And if you talk about specific sewage treatment plant, we have a larger capacity, bigger plant installed in Delhi Jal Board. I don't know. I'm sure that many of you would have visited Akshardham. Next to Akshardham, this was a prestigious project for CWG, Commonwealth Games job. It's a big plant, a bigger plant, 4.5 MLD. So it's running since 2010.
Yes. Then I think because for a very big plant, this MBR, I was also not knowing where it is. So it is near for Delhi Jal Board you have designed.
Yeah, Delhi Jal Board, and you'll be surprised. The biggest in India, or which is coming up in Mumbai. very soon you will see in Mumbai, Bandra location, they already floated a tender. It's a big, huge plant, but we are not participating in it. Yeah,
Okay.
they most likely it will be a huge, big, very big plant in India.
Because reuse, if we can reuse the water, then only I think so much investment is we can do. Otherwise, I think membrane system, if we are not reusing the water, then this much installment is not necessary also.
No, no, what happens is you're absolutely right. Given the scenario is like why one would go with an MBR? You should have a driver, right? Uh, like if I'm preferring MBR, I have some issue. Like I'll have an issue of footprint, right? My available area is only this much, where conventional treatment plant will not come in, right? That is one case scenario. The second case scenario is, right, I have already an conventional treatment plant, but I'm not able to expand further, right? In that case, MBR will come in picture, right? Number two. Number three, people want to use this water for for their utility purpose. When I say utility purpose in industries, they use it for boiler makeup or cooling tower makeup water, right? Done. It makes sense. Or last but not the least, people should have an corporate social responsibility. While they discharge the water, they should discharge a clean water, right? There are many corporates, right? They are not doing anything, but still they have an MBR system. They simply, like, I'll talk about Infosys, right? They are not reusing those water, but it is their environmental social governance, right? Their policies say that whatever we discharge from our facility, it will be in clean water, and it will not hamper the downstream, the receiving body. It will not hamper the receiving bodies. Problem is, what will happen is, uh, here in MBR you are getting less than 5 BOD, right? If you go with conventional treatment plant without any BNR, biological nutrient removal, it is 30, less than 30 BOD, right? In India today, right? I'm talking about the only the municipal side, municipal corporation who owns the sewage treatment plant. It's running at barely 55% capacity. That too untreated, and it is affecting the receiving bodies, right? Which is causing a eutrophication, because you shouldn't forget, right? It is coming back to you only. The municipal sewage treatment plant, right? They usually treat the water to the discharge norms, and they discharge it to the receiving body, that is a river, nearby river, right? It is coming back to us only as a drinking water, right? After further treatment. So it's a sense social responsibility one should have, like whatever they discharge, they need to discharge the clean water, so because it's coming back to us only.
Okay. Any other participants want to ask the question? Yes, Dr. Umar.
So after the membrane use, we can use
Madam,
the.
can you speak a bit louder? I'm not able to hear.
Sir, actually, the membrane can be reused for some other purposes, or it can be disposed of after the treatment.
Can we use this membrane for some other purposes? Like
Yeah,
you're talking about those damaged membranes?
damaged membrane or used membrane.
Uh, ma'am, like once you use those membrane, right? You'll for you it will not be of any use. You need to safely dispose it,
Okay.
because these are all polymeric membranes. It's not environmental friendly membranes. So you have certain procedure for disposing those membranes.
Okay. So any environmental factors to be affected, environmentally it will affect the soils, or how the disposal method, all those things.
Madam, sorry, your voice is too low. Probably you may have to speak. Are you asking for any alternate membranes available which are environmental friendly?
How it can be disposed of, or whether it can affect the environment, like the soil stratum or air. So the disposal method.
Okay, disposal method is it's simple. Like you have to recycle the plastic. There are people available, right? Where who does the recycle of the plastic, right? Like I'll tell you, we have a case in Mangalore refineries in Mangalore, where it was installed somewhere in 2011, and we have replaced most of the membrane. It's a bigger plant, 14.5 MLD, right? So those membrane plates have been taken out for recycling. They'll recycle those plastic.
So yeah, that can be recycled for.
It's a plastic, right? It's a plastic material, so you can shape it out.
Okay, okay, okay. So which is economics for using the membrane for water treatment or wastewater treatment?
Sorry, ma'am, this membranes are?
No, which water treatment or wastewater treatment, which membranes are economically feasible?
You're asking like these membranes are used for water treatment or wastewater treatment?
Yeah, which method is feasible? It can be adopted for either wastewater or water treatment.
Yeah, both. Actually, if you see, the same membranes can be applied for water treatment also, right? Where there the dynamics and the design process will be something different, right? But most commonly, these submerged membranes are, especially I'm talking about the polymeric membranes, right? Will be used for sewage application, sewage or industrial effluent application, I would say.
Okay.
And
So,
and for clear water treatment, you have specialized membranes available. See, these are all submerged membranes. Membrane bioreactor membranes, those are all submerged membrane which are immersed into the aeration tank or a separate tank, right? You have membranes available uh, which is kept outside the tank. Yeah,
okay, so thank you, sir.
thank you.
Thank you.
Other participants, if they want to ask a question.
Hello, am I audible?
Yeah.
Sir?
Yeah, Professor Joshi sir.
Yes.
You are
How
also
are you,
here.
sir?
Welcome, sir.
Thank you. So, how is your ATAL FDP is going?
It's very good, sir. Going very fine.
Good. So, Sujit sir, thank you very much that you delivered very interesting talk to our
Thank you, sir.
participants.
Thank you. Appreciate that.
That was really interesting.
Yeah.
I have a
In
question.
fact, I want to. Yeah, sorry.
Yes, someone has
This
a
is
question.
Dr. P. Kanagaraj
Okay,
from
Yeah,
Tamil Nadu.
yes,
Yeah, I
doctor.
have one question, sir.
Yes, sir.
So
Yes, please go ahead.
nowadays, many research develop anti-fouling membrane. So in that membrane, we need a cleaning method or not?
Sir, I haven't heard about this anti-fouling membrane.
Yes.
What we knew, or as an OVO or I knew, is because I'm in this field for more than 23 years now. Like any membranes are bound to scale or foul, right? Because the process is as such, right? The key lies in the material, the type of material which you use, right? I'll just briefly morely touch on, because I didn't discuss anything on advanced membrane, which even OVO has, right?
Okay.
Whatever I discussed today, it was all on polymeric membranes.
Okay.
As an OVO, we have our own silicon carbide membrane, right? It's made out of rocks, right? These polymeric membranes are made out of, it's a petroleum product, right? It's made out of plastic. It's
Okay.
not environmental friendly, but our membranes are made out of it's literal rocks, right? It's a ceramic material with the SiC coating, silicon carbide coating, which is very toughest material, right? Silicon carbide is toughest material after the diamond. These membranes have ability to withstand any extreme conditions, right? I'll just give you an example, right?
Okay.
These polymeric membranes cannot withstand temperature more than 40 degree. Okay.
Okay.
Whereas silicon carbide membrane can withstand temperature more than 80 degrees.
Okay, good.
Okay. Polymeric membranes can withstand transmembrane pressure of 3 psi. Okay. Silicon carbide membrane can withstand transmembrane pressure, that is TMP, of 10 psi. Okay. Polymeric membranes can take the flux, the amount of water it can pass through per meter square of membrane area. Is, let's say, I'll give you an idea, just right. I'll give you a thumb rule. If polymer is taking 10 liters, silicon carbide can take 40 liters within the given area, per meter square area. Right?
Okay.
That is the advantage. Beyond that, the main advantage is it can withstand any extreme condition. When I say, like, in polymeric membrane, you have a limitation of pH, right? 3 and 11 pH. You need to operate between that, right?
Okay.
Whereas with our SiC silicon carbide membrane, you can operate between 1 to 14 pH. Let's say, for example, if something goes wrong with my membrane, even my membrane is bound to scale. My membranes are silicon carbide membranes are bound to foul, right? But I can go for an aggressive cleaning, right? I can clean these membranes with let's say 1 pH, right? I can clean this membrane with 14 pH, whereas that liberty is not there with polymeric membranes.
Okay.
Right. That is the reason these membranes, right, is easily recoverable. It'll come back to the original situation. Right. Silicon carbide membranes, you after cleaning, you do the aggressive cleaning, let's say 2 pH or 1 pH or 14 pH, it'll come back to the original position where it was, right? It is recoverable. But polymeric has got certain limitation because of this pH chemical susceptibility, right? Between these 3 and you have to play between 3 and 11 pH only. If you have an aggressive scaling or an aggressive fouling on your polymeric membrane, you cannot go and clean with 2 pH or 1 pH or 14 pH because that membrane will get damaged.
Okay.
So that this is a new generation membrane which we have launched 3 years back, and we have been successfully promoting everywhere. It can withstand any condition typically. So I'm sure that future lies with ceramic membranes. Polymeric membranes will be out because of its maintenance as well as the life also. This ceramic membrane life is 20 years, whereas polymeric membrane life is only 5 years. Some people claim 7 years, maximum 7 years. So yeah, you have various advanced membranes available, but I haven't come across any anti-fouling membranes.
Yogesh Chaudhary, है ना?
Yeah.
Thank you, sir. Thank you. I clear, sir. Okay.
Yeah, great, Dr. Nagesh.
Any other questions?
Okay, thank you.
Any other questions?
So I have another doubt, sir. It is a doubt.
Yes.
Sir, have you know any membrane industry in India? Can you list out some membrane industry in India? It is very useful for us.
Sanjay Chaudhary नाम नहीं है, योगेश
Membrane,
Chaudhary.
are you saying membrane industry, like membrane manufacturers?
Yes. Membrane manufacture industry.
Yeah, like you want to tell me now? Okay. You have Suez, you have
Yes,
Kubota, you have Ovivo, you have Torre,
okay.
you have Coach membrane, you have Mitsubishi membranes,
okay.
You have what? You'll find a lot of other Chinese players. I just spoke. I just listed only the global brands who are operating across the globe.
Okay.
And you will find various other Chinese brands also.
Okay, sir.
And Chinese and Korean brands are available.
Okay, sir. Okay, thank you, sir.
Thank you.
I think if any participant is there, they can ask. Otherwise, if there's no question, then we will end this session. We are very much thankful to Mr. Sujit from Ovivo. He has yesterday only we have talked about the membrane systems, and today we have seen the application part of it, like in membrane bioreactor. So it is very much fruitful that we got a industry resource person who is directly linked with this water treatment using the membrane. So I am again thankful to Mr. Sujit. Thank you.
Yeah, thank you so much. Appreciate everybody's patience of listening it, and yeah, it's a great honor to be a part of this program. Thank you very much.
So this will be the end of. Yes, yes, sir.
Hello.
Yes,
yeah,
sir.
yes, sir. Yeah.
Sujit ji, thank you very much. You really delivered very interesting talk to all our participants. I'm sure it will be very much helpful. Even they can go for some research in this area also.
Yeah, absolutely. I'm available, Sanjay sir. I'm available anytime. Both Mr. Singh and Mr. Joshi, right? I'm available anytime. Any infos, right? If you want us to deliver a separate lecture on advanced membranes, yeah, we can do that also.
Sure.
We'll be happy to do that.
Thank you.
Thank you so much. Appreciate it. Bye bye. Take care. Bye bye.
Bye. Bye.
So we are ending this session here. I think we'll be having your exam. We have scheduled at 3:15, but as time will be there, just we will discuss, and then I will within, I think before 3 o'clock also we can have, just we will be